Number 54 asks us to rewrite our conclusion from number 53. This was our conclusion from number 53. Before we rewrite it, let's review exactly what R sub n stands for. An infinite series converges to some value s. S stands for the infinite sum, and it's equal to the sum of the infinite number of terms. We can rethink of this infinite sum as the nth partial sum, a sub 1 plus a sub 2 up to the nth term. That's what the nth partial sum has always meant, plus the rest of it, or the remainder of it. R sub n is a sub n plus 1 plus a sub n plus 2, etc. Okay, so R sub n is the infinite sum minus the partial sum. In other words, the sum of all the terms minus the sum of the just first capital N terms. Well, that's it. This is the nth remainder. We can just substitute it in there, and let's see what we get. I will just add this expression to both sides, isolating this. And obviously the infinite sum is larger than the partial sum. So this, the infinite series, that's really the part of this problem that's in question, we know is going to be always between the partial sum, the capital Nth partial sum, and the capital Nth partial sum plus the definite integral from capital N to infinity. And so since we're dealing with the infinite series that we know converges, we don't know what it converges to, but we can sandwich it between two boundaries and have an idea of what this infinite series is equal to by using the nth partial sum and the result of problem 53, which says that the remainder will always be bounded by this definite integral. That's it. We've proved what they asked to in number 54, and now we're going to see the benefit of this idea. Estimating the value of an infinite sum by using the nth partial sum and the conclusion from number 53 when we do problem number 55, which there will be a separate video for.